Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome to the second day of the Geoinformation Science Symposium. And today we will have... You cannot hear me? Can you hear me, Professor Yan Liu?
Can you hear me?
Yeah, I can hear you, actually.
I cannot hear you.
Oh, okay.
Excuse me, can you hear me clearly over there?
I can hear Mas Andi.
Okay. And Professor Yan Liu, can you hear my voice on your device? No, not yet.
I think.
Recording in progress.
Can you hear me now?
Yes, I can hear you clearly.
I can hear actually.
Oh, okay, good. I can hear you now. Okay, great.
Okay.
I couldn't hear you before.
Yeah,
Okay.
yeah, no problem.
That's good.
Okay, can you hear me as well?
Yes,
Professor?
I can. Now that's all
Okay.
good.
Okay, good morning, everyone. Welcome to the second day of the Geoinformation Science Symposium. And today for the first plenary speaker, we will have Professor Yan Liu and Professor Mei-Po Kwan. But before that, let me inform you the agenda for the second day. So the first agenda is the first plenary speaker from Professor Yan Liu and also Professor Mei-Po Kwan, and will be moderated by Dr. Sandi Budiwibowo from the Science Information, from the Geographic Information System Laboratory. And the second agenda is the invited speaker from Dr. Agustan, and also the workshop session from the Geographic Information System Laboratory at the 11 to 12. And after that, after the break, afternoon break, we will have the second plenary session from Dr. Dani Aribasbel from the University of Liverpool. And also it will be followed by the paper, the manuscript presentation from the submitted abstract. And let me also inform you that the Dr. Matthew Blackett from Coventry University cannot attend the GSS because he is sick now. So we will let's pray for speedy recovery for Dr. Matthew Blackett, and he said apology for cannot attending this Geoinformation Science Symposium. Without further ado, I will transfer this session to Dr. Sandi Wibowo. Please, Dr. Sandi Wibowo.
Thank you very much, Dr. Sanji. Good morning, ladies and gentlemen. Welcome to the GIS plenary session of this Geoinformation Science Symposium. And then I would like to, first of all, introduce myself. My name is Sandi Budiwibowo, and I'm a lecturer at the Department of Geographic Information Science at the Faculty of Geography, Universitas Gadjah Mada, and I am I'll be serving as a moderator today. So this morning we have two speakers, if I'm not mistaken. The first session will be Prof. Yan Liu. She will deliver 45 minutes of presentations, followed by 15 minutes of question and answer. And then the second session, Prof. Kwan Mei-Po will also deliver 45 minutes of presentation, and then followed by 15 minutes of question and answer. So now allow me to introduce Professor Yan Liu by reading her outstanding curriculum vitae. Professor Yan Liu is chair professor at the Geographic Information Science at the School of Earth and Environmental Sciences of the University of Queensland. She is a quantitative human geographer and a special data scientist. Her research focus on developing cutting-edge methods for the collection, analysis, modeling of spatial data to provide science-based decision tools and data-driven solutions to a range of social environmental challenges in our urban and regional space. She's currently serving as a scientific advisory board member of the Australian Urban Research Infrastructure Network, and then steering committee member of the IGU Applied Geography Commission, and editorial board member of Environment and Planning. So Prof. Yan Liu will deliver a presentation on climate gentrification, an emerging phenomenon in coastal cities in the era of climate change. This would be very interesting presentation. So please welcome Professor Yan Liu. You have 45 minutes of presentation and followed by 15 minutes of question and answer. Thank you.
Thank you, Dr. Sandy. It's my great pleasure to speak at this forum. I suppose you can hear me, right?
Yeah, I can hear clearly.
Okay, great. Let me just get my PPT slides, share this slides, and then I can start the talk. Share screen. Okay, so put this aside a bit. So let me just organize my screen. So that should be all good. The topic that I'm going to present today is about climate change, climate gentrification. And I'm going to talk about this emerging phenomena, and then a theoretical framework that we introduced to explore this concept and the phenomena. And I'm going to also follow with some empirical studies in one of the coastal cities in Australia, the Gold Coast, to see how we can explore climate gentrification, or you will see what I mean by climate gentrification in a minute, and then see how we can explore and then understand the policy and then practical implications. So to start with, we know that the global climate is changing. There are ample evidence to show that the temperature is warming up, and then it's warming up faster than before and than any other time in the Earth's history. Coastal cities in particular will see a continued sea level rise throughout the 21st century. The latest IPCC report, I'm sure a lot of you have read this report, shows that cities are changing. There are 2 degrees increase, and then some aspect of the climate change may be amplified, including heat and the flood from heavy precipitation event and the sea level rise, in particular in those coastal cities. So we will see these changes over time. Some of the examples of pictures that I put it up here to show the various aspects of impact of climate change combined with the other hazard, like sea level rises that are emerging, flooding, inundation, storm surge is another aspect, and the tsunamis and erosions. I'm sure that in Indonesia, as in other coastal cities, this kind of hazards are seen more frequently than before. This is like a picture about the Brisbane flood that occurred in 2011. I wouldn't say that it's entirely or climate-related or climate-induced event, but the scale and then the impact of this flood is enormous to the cities, and then how we consider and then deal with this changing phenomena is something that we have to deal with as planners, as geographers, and then as people working in this field. So today, I'm actually not going to talk in general about climate change, but rather looking at how climate change impact on people, and then the impact of this, the social impact that could be causing a new wave of gentrification. So as we can see that climate change impacting everybody, however, different people could respond to this impact in different ways, and then the extent of that impact, and then the way that they can adapt to such impact is also different. And then in that way, that we would theoretically consider that could cause gentrification through this impact. So let me just briefly review and then talk about gentrification as a social change in our societies. Gentrification has been studied extensively since the 1970s, and it has been recognized as a process of residential displacement whereby low-income residents are relocated from their current home to a different neighborhood, resulting in the change in social classes. Okay, so it's ultimately is a change of social classes. The global climate change is recognized as a threat to the low-lying coastal cities, causing that new wave of climate change. However, a range of media report and then some of the articles are bringing this concept. There is a lack of empirical and the theoretical work to explore the existence, how we can explore this phenomenon and so on. So this talk is one of the first steps that we want to share with you, how we want to propose research in this field. I wanted to briefly review the 5 waves of gentrification. You can consider each of the wave as different drivers that cause the gentrification, different societies or groups that are affected, and then the different gentrifiers and then the outcomes to the different wave of gentrification. So the early wave is more of sporadic, is like ad hoc kind of phenomena that was driven by individual homeowners and the renovators, that they renovate their home, improve their conditions, and that resulted in the improved environment or living conditions. So that occurred in the late 1960s to the early 70s. These are reported in New York and other cities and a range of other places as well. And then in the 1980s, more of those like gentrifications was reported, which was largely driven by private developers who identified areas and then developed and then attracted new like middle-class families to live in those new development homes, and then causing a second wave of gentrification. And then the third wave is The second wave is considered as small developers, individual activities, where the third wave is more of the large-scale developers working with government, and then the government, and then like the state-led gentrifications develop in certain areas, and then causing the change in social classes in the areas. The fourth wave, which is more occurring in the early 2000s and then up to the financial crisis in 2007, is more of the financialization of the homes. And that has been considered a new wave in the early 2000s. And then after that is what we consider the fifth wave, which is more varied and then have a range of other terms that has been used, like it's more of the environmental, ecological gentrifications, which does include, we position that in the climate-induced gentrification into that category. Okay, so I would just illustrate in this chart to show the fifth wave of gentrification, which is more environmental or ecological related or driven. And then it encompasses a range of other terms here, like for instance, high amenity gentrification, transit induced gentrification, like toward development, and then cause the change in the social classes in the areas. Tourism-induced gentrification, education-led gentrifications, like the university towns and then areas that are developed around those university towns. Green gentrification, no carbon, new development, and rural gentrifications, and all those terms that you may have seen that in the literature. And that's where we position that climate gentrification is also environmental change related, and then the emerging phenomena given the change in the climate and then hazard that are people responding in different means and different scale. So climate gentrification is recognized as an emerging process of human settlement and the social change that are triggered by climate change. There are some terms that used climate-induced gentrification. We initially also used the term, but changed it to climate gentrification after some comment in the reviewers. And then given the fact also there is limited evidence to say that climate is the drivers to the gentrifications, as you will see in my talk later on, that there are multi-factors that are contributing to the new emergence of gentrification in the current age. So it's driven by concerns of the risk of climate change, including the sea level rise, storm surge, coastal erosion, and then the extreme weather event. So it's all related to climate change. The varied level of resilience and the capacity to respond and adapt to the climate change impact because of the social, economic status, the demographic features of the classes are fundamentally causing those class change in response to the impact of climate change. So one of the early work that was published in 2018 is by Keynote and then his co-authors in Environmental Research Letters. If you are interested, you are very welcome to read this paper. It's a really good paper, I believe. So they identified different pathways, possible pathways of climate gentrification. One of that is they call it superior investment pathways, where there are both high risk and low risk areas. The investors will choose areas of lower risk and then to develop housing and then to attract people to move from high risk areas to the low risk areas, causing the change in social classes. This is considered as the superior investment pathway. And this is more occurring in the no risk areas. That's where the gentrification is occurring. Then the second pathway is called a cost burden pathway. They have some examples to illustrate where this happens. Those are the names like Miami Beach is one of the example that they identified as the superior investment pathway. Cost burden is basically saying that because of the impact of climate change, then the cost of living in those coastal areas are higher. There are more, the higher insurance costs, there are higher rates and other costs involved, and then you might have to buy and then pay for higher rates for maintaining the infrastructure and so on. So this forces lower income families to leave those coastal areas and move to other places. So only those richer and then people who can afford in those coastal areas will stay, and then causing the gentrification that you will see is more in the higher risk coastal areas. And then the third pathway is the resilience investment. Is well, there are through engineering, through other investment to improve the facilities and then the infrastructures to protect the areas from the climate-related hazard. So this type of pathways can occur in both high and low risk areas, depending on how the infrastructure and the development are laid out in those areas. So the three pathways are identified and then they exemplified, and then there are some empirical work also illustrated using the Miami cases in the paper. So this is an example that are illustrated, also related to that empirical work. Apart from Kenan's research, there are actually quite limited work, even though that we can see increasing number of media report and then social media discussions to talk about climate-related gentrification, and then the like the different terms involved, like migrant, climate migrants, and then so on. So what we have recently proposed is a tri-disciplinary approach and to position climate gentrification from a social, geographical, and environmental science perspective. We consider that the multiple dimensions of this concept, incorporating both the social, geographical, and environmental aspect. And then we also considered other type of like gentrification in the environmental related along this chart as well. And then so from these three dimensions, we can see how we can identify possible causes, factors that can lead or contribute to climate gentrification. So in the before I talk about an empirical study, we also have done a global scan of cities that are potentially subject to climate gentrification. This is not, as I mentioned, that this is not sufficient evidence, but rather discussions, media report, or some of them are like this one, Canons have an empirical evidences to show that. So a more detailed scan and the discussion about those areas across the continent can be seen in our recent paper as a book chapter here I listed in this slides. Okay, so without any further ado about the concept, and then I wanted to see how we wanted to explore empirically the possible existence of gentrification that may be related to climate change, and then, or even if we can find evidence, the causes of this climate change related to gentrification. So we selected Gold Coast, coast city, a very tourism related city in Australia, and then to see whether we can identify gentrification, and then whether we can relate gentrification to climate change impact, and then to see how it may, how we can understand the drivers and then the implications. So the analytical workflow that are illustrated in these slides. So we started by identifying gentrification. So I wanted to say that is not, we are not saying that this is climate gentrification. We are rather identifying gentrification. I will show you the way that we did that, measuring gentrification, and then to see whether it exists, and then examining whether the relationship between gentrification and then the built environment features, and then also further to look at those gentrification with both built environment and the geographical or physical environment that are related to climate change. And then we identified a series of indicators or factors that we use to measure and then model this relationship. And then in terms of identifying the gentrifying areas, this was done from a social science perspective. We used a series of indicators relating to occupation, qualification, household income, rental status, household composition, and also the land value change as the indicators to measure gentrification. This is based on theoretical research on traditional gentrification concept. And then we look at how the built environment features from geography perspective, the 3D factors, the design, density, and diversity features may relate to the gentrification, the existence of this gentrification. And then we look at from the environmental science perspective, how climate related, like possible, like proximity to water bodies, to the coast, and then to land elevations and so on, impact relate to gentrification. And then from there, we might be able to link gentrification with climate change. And then in terms of that environmental conditions, we actually set up 3 scenarios based on possible scenario rise. And then the baseline scenario is that scenario 1, where we identify areas of higher risk, like the three scenarios based on sea level rise at 0.8 meters, which is defined in the IPCC report as the baseline conditions. And then we have the extreme case, the 7-meter sea level rise, which is not really sea level rise, but also considers the storm surge. And this is based on historical data, historical record, like the Yasi, the recent Yasi, like storm surge went 7 meters high in the eastern coast in Australia. And then we pick up in between 3.7 as and medium risk level as the second scenario in the case. And then by doing that, we identify 3 zones, areas within 0 to 0.8 meters are considered as high risk areas along the coast. And then between 0.8 to 3.5 meters as the second zone, and then the third, and then the fourth zone, which is above 7 meters, which is more towards the inland area. So then we develop models to identify the relation, the correlation between gentrification and the environmental factors. Let me get to the next slides to show first the kind of data that we used for our empirical work. From the social science perspective, we measure gentrification. So we use census data considering the social economic status, but we also obtained valuable data in terms of land value. All of the data we consider 2 time slot because gentrification is a dynamic process, is a measure of change over time. And then, so we used social economic and demographic data to measure gentrification. And then we used the 3D measures to quantify the built environment features. Those data were connected from digital cadastral database, from the Southeast Queensland regional plan, and then the Queensland spatial data for the consortium. So in terms of the environmental green space features. Then the natural environmental data, we have a digital elevation model. This is from NIDA data, the higher resolution digital elevation to identify areas that are under different sea level rise conditions, and then hydrological network, and then the sea level rise scenarios that I explained before. So the kind of data sets from the environmental perspective, I illustrated only a few of that. Like distance to the water bodies, there are a lot of man-made canals or human-made canals in the area, apart from the coastal regions, and then the lakes getting into the inland areas. And then you can see that further towards the west is the higher elevated areas with higher digital elevation and then more of the flat areas along the coast. So in terms of the measure of gentrification, I want to just introduce the method that we used for this work. So we measured gentrification using 6 sets of indicators. map is not map in our cartography perspective, is managers, administrators, and the professionals. That is one categories of professions recorded in the census data. So we measure the percentage of managers, administrators, and the professionals in the total population in each of the unit that we measure. The smallest unit in the census is in Australia is called statistical area 1, which is actually quite small in geography. About the second level, which is the SA2, is about 1 suburb. SA1 is much smaller as compared to a typical gazetted suburb. And then we also look at people holding a bachelor's and above degree, so education levels. Gentrification is typically higher income professionals with higher educated or like single coupled families without children moving and then gentrifying, moving to other places. So those are the indicators. Existing work typically identify and use 1 or 2 of these indicators. What we are doing, we are using a set of these indicators, and then we aggregated them to measure whether we can observe a certain aspect or all of those aspects to consider areas are going through gentrification or not. And then the land value data is another addition in other than the social economic data that we use to measure the change in the conditions of the area. So each of the data we measured as a binary variable. So with one to show that in that particular indicator, it is gentrifying, meaning that the change of, for instance, the percentage of map in total population, the change of that indicator in that small local area is higher than the average change of the percentage of map in total population for the whole city. So in that sense, if the change in the local area is faster or higher than the average of the whole city, then in that dimensions, we are considering that it's gentrifying, a gentrifying indicator, the same as the others. If it's lower than the city average, then we code it as 0, not gentrifying. Then the gentrifying indicator is the sum of all the 6 indicators. So you can see it can range from 0 to 6. So rather than having all the 6 categories, we group them into a low and a high for modeling later on. I see if, okay, that is not related to the talk, just in case the slides is not coming up. Okay, so we group them into a low and a high category with 0 to 3 as not gentrifying, and then only it means that there is not enough evidence, while 4 and to 6 indicating that there is more likely have the evidence. So the second part is in terms of the data analysis and the modeling part. I mentioned that we connected a range of the built environment features from the design diversity and the density perspective. There are overlap, and then so rather than using all the indicators, we did a principal component analysis to identify 3 principal components. And then you can see that the eigenfactors here, that's how we choose the top 3. With an accumulative percentage that can explain all of that at about 74%. We could go to the 4th factor, so to get to the 85%, but we didn't select the 4th component, so we only used the 3. And then the 3 principal component 1 is more of the factors encompassing housing density, access to public transport, housing diversity, road density, where component 2 includes distance to the CBD and then the lot size, the land size. And then the 3rd component is about green space and land use diversity. So in terms of the modeling approach, we did 2 models. One to use 3 principal components to explain how the built environment factors explain gentrification. So the binary logistic regression was used. That's why we have the low and high. And then the second model, in addition to the 3 principal components, we also added the natural environment factors like land slope, elevation close to like proximity to coast and then to water bodies as the additional factors that are included in the model. And then for each of the model, we run our data, we run for the whole study area, and then we also apply for each of the 4 zones along the coast, medium, and then no risk to the further inland areas as the 3 zones under the 3 and for the 4 zones under the 3 sea level rise scenarios. So this is the first set of results in terms of gentrification. So yes, no, to show areas that are gentrifying or not. That's the 6 individual indicators. So I mentioned that 0 is no gentrifying and 1 is gentrifying. However, this is just one indicator. It may not reflect in other indicators. That's the good thing about having multiple indicators to quantify. This is the aggregate effect about the gentrification index. And then we consider that the no value, even there is 1 or 2 indicators to show that there are maybe starting sign of gentrification, it's not sufficient to actually identify. The areas that are more prominent about like to show gentrification sign is towards the northeastern coastal areas, like here in this part, and then also along the eastern coast. There are also some areas inland, particularly in these areas, which is all around the canal area, like areas that are canals, and then high and then very expensive houses located in those areas. So this is the first part where we measure the gentrification using from the social science perspective. And then this is again also the a chart to illustrate the distribution of this gentrification by the 3 zones. So within the local the high risk coastal zones, there are 2,222 SA1 in these areas, and then about 10% of the areas having above 5 or 5 to 6, very like hardly have seen any sign about a 6 in these areas. And then in the second zone, 185 SA1 areas within this zone, and then around 6% of those SA1s have showing sign of gentrification, and then you can see the other part there. So we can see that gentrifying areas exist across the whole city region in Gold Coast. More areas are gentrifying along the coast under this one in terms of the proportion wise than those inland areas. And then so you can see this is a part of the areas that actually have a lot more water bodies. Did someone want to ask?
No, I don't think so.
Okay.
Go ahead. No, don't worry.
Okay, good. Okay. And then so the next part is in terms of the modeling work. As I mentioned that we first identify gentrification, and then we want to see whether gentrifying areas or areas gentrifying or not relate to the built environment or the built environment and the physical environment features. So the model 1 considers only the built environment features, the 3 principal components, and then we run it for the whole city, and then for each of the zone areas. You can see that all the most of the principal components are significant at 0.01 level, and then the pseudo R square isn't as high. But when in model 2, when we introduce the building, the physical environment features like elevation, slope, distance to water, and the distance to the coast, the R square values all consistently and substantially increased across all the areas in all the models. And then all of those factors are also significant at P at 0.01 level. So what it can tell, it shows that elevation, distance to coast are, as you can see, those are apart from the elevation, distance to the coast are positively related or associated with the level of gentrification. Well, land slope and then the distance to water, which is more towards the inland areas, flat areas, water bodies, canals, higher, like more expensive waterfront properties located in those areas. Those slope and distance to water are negatively associated with gentrifications. And then areas in higher elevation and away from the coast are more likely to be gentrified. That's what we can interpret from the results here. And then also those that are in steeper slope and located closer to waterfront are the same case. So this is the binary, the regression results that we identified. So what we can find, and then how we can interpret and understand those findings. So firstly, we think that uncovering the potential existence of climate gentrification is important to mitigate the impact of climate change on coastal cities. And particularly when we talk about adaptation, we will talk about the impact of climate change on people and household. And then the second model in our work shows that elevation, proximity to coast, social, economic, and demographic features of household, and the 3D factors, density, diversity, building, and the design, all collectively contribute to relate to the level of gentrification. So there are statistically evidence to show those factors are related. So here we are exploring the correlation rather than the causation. We are not saying that this is causing gentrification. And then if we can actually say that, then we are more confident that climate gentrification is existing in these areas. So to explain the varied landscape of gentrification and then the way it relates to those different features like built environment and then the physical environment features, we can relate to the different pathways that were identified and discussed in Keynote's research work. Gentrification in certain high elevated inland areas are possibly related to that first, and then the third way of pathways, the superior investment and then the resilient investment pathways. Developers are moving away from the higher risk coastal areas and developing more of the residential areas inland for investment properties. And then also the resilience procedures invested along the coast are causing the variations in different parts of the areas for the gentrification. This is accompanied by the upgrade of these local build-up areas, the improvement of those areas like large green spaces along the coast in certain areas. And then so it also overlaps with green and environmental gentrification rather than just climate-related gentrifications. And then the no-name properties in the coastal strip are possibly also associated with the second pathway that were identified in Keynote's work, the higher level of gentrification, possibly that is because of the higher risk, increased cost of living in those areas, and then forcing lower income household to move away from those coastal livings. But this is also related to the fact that the coastal areas is primarily occupied by those luxury high-rise apartments, hotels, resorts, and the commercial buildings in the case of the Gold Coast. a very internationally well-known tourist destinations, as we all know. So here we are talking about the correlation between gentrification and the built environment and then the physical environment features. We provide statistical and empirical evidence to identify their relationship. However, we will need to have further information to understand the possible causality, whether really is climate change that is causing, or at least is the concern of people about climate change that are causing people to leave or choose to live or choose to stay in certain areas. So further work is required in that regard. And in fact, that one of our PhD research is to conduct a survey of residents and the community groups to understand how they concern about climate change and how when they choose where to live and then whether to relocate in their house in certain areas. So there are certainly ongoing work that needs to come into this type of research. However, we can certainly move further to look at some of the practical and then policy implications for understanding climate gentrification and then to better respond to climate change and adapt to the situations. So understanding climate gentrification is important for residential, for understanding the residential mobility and then the settlement patterns, and then even for the real estate market change, and more broadly for city planning, environmental design, and urban governance. Government adaptation plans and then hazard prevention policies need to consider, we think, more vulnerable groups, whether they are unwilling to move or whether they are unable to move as their priority.
Excuse me, you have 1 or 2 minutes left for the presentation?
Yes, so I'm getting there. Thank you.
Yeah,
thank you for reminding me. Yeah, and then government needs to work with the private sectors to render the built environment re-engineered to be more climate resilience. There are a lot of work in this space. So the joint connections about designing the re-engineered environment is important. Public participation, community engagement, and education are vital to the success of adapting to the climate change. So in conclusion, I think I'm getting to just about on time. We consider that global climate change calls for collective effort in developing adaptation strategies and models to understand and test the impact of climate change on coastal city development. Climate gentrification is, at this stage, is still an emerging concept, and then that needs that can be used theoretically to explore the impact of climate change on people and then the social class change in the neighborhood. We have proposed a tri-disciplinary framework encompassing social, geographical, and environmental sciences to try to understand and explore climate gentrifications. We have done an empirical study to show gentrification does exist, and then gentrification, the existence of these areas that are gentrifying does correlate and then can be explained by their correlation with the built environment and then the climate change related factors. However, there are more theoretical and analytical work that is required to explore the existence, the nature, and then the evolving dynamic of climate change globally and across all areas. And then Indonesia is actually a really good place to study this phenomena and to understand how climate change impact on human settlement and urban change. So with that, I will stop here, and then I would welcome questions and comments for the talk. Thank you very much.
Well, thank you very much for delivering such interesting topics. So I really appreciate it. So we are now entering the question and answer session. If you have
yes. Should I just stop there sharing the screen sharing, right?
Yeah. Okay. No problem. So maybe the participants have or has a question. One question maybe here in the chat box. I am very interested in your explanation regarding the modeling of the vulnerability of coastal cities to climate change using logistic regression. What if this modeling is combined with the other factors such as land subsidence?
Actually, that is a really good question. So I think in particularly in Indonesia's case, the land subsidence is an important factor and then could be a really useful environmental or climate-related factors to add it into this modeling framework. In fact, I have some collaborations with a group of researchers in Indonesia looking at land subsidence using GIS. So it could be really combined with this climate gentrification if we consider the human responses to the hazard and how it impacts on the social change in the communities.
Well, thank you very much for the answer. Is there any other question regarding to this presentation? No question?
Okay, very good.
Otherwise, I will ask you. Well, otherwise, I will ask you one question.
Okay.
What is the main challenge when you measure the gentrification?
Well, to measure gentrification is actually not as challenging. We have used the method that actually adopted from another researcher in Australia, but modified and then using a set of indicators. However, the most challenging part is actually to attribute gentrification to relate to climate factors. So there is no historical data that we can actually use to show that the cause of gentrification is because of climate change or climate change factors. So this is the most difficult part, and that's also where we are conducting surveys. We are looking at surveys actually of a range of people, planners, as well as most residents and the community groups, and then to see how they consider whether climate change is a factor, or whether they are choosing to live in higher elevation areas because they are concerned about the impact, or they choose to live in the coastal cities because they are more rich and then they can afford to the increased cost there. So I think the most difficult part is more to affirm this is climate gentrification.
Well, thank you very much for the answer. We still have 1 or 2 minutes for question and answer. Well, you have one other question here. I read some news that mention forest fire in Australia. Are forest fire in Australia caused by climate changes? Can we use your logistic regression model method for this forest fire event, and how the remote sensing data in GIS can help with this forest fire hazard? Thank you. From Ilham Jamaluddin.
Okay, thank you for the question. I haven't done any research actually looking at like a forest fire in Australia. In particular, I joined a group of discussions, and then we were talking about like developing a larger scale project earlier in the year, but we haven't really get into it in my group. So I wouldn't say I'm an expert on that. There are actually a lot of research in Australia looking at modeling forest fire, and then particularly the bushfire happening every year. Whether it's related to climate change, hard to prove. Actually, climate, like the dry seasons, definitely contribute to the emergence of bushfire in Australia. There are also human factors there. A lot of times that those bushfire are triggered by camping and then the fire, but also very, very dry seasons during the Christmas time. So it can be related. Whether we can use logistic regression model for the forest fire, probably that is the baseline. Logistic regression is, this model has been used actually in bushfire modeling, but there are also other methods that has also been used there as well. So if from methodologically can or not, yes, it can be used to model bushfire. If we can identify the causes and then we identify the appearance, how we can establish those relationships. That's fundamentally what regression model is about, right? But how good it can be used to explain the case, I cannot say because I haven't done that yet.
Well, thank you very much. I guess the time is up, and then thank you very much for this interesting discussion. I really appreciate it. So
thank you very much. And I can see that Prof. Mei-Po Kwan is ready for her talk. Great.
Yeah.
Just want to say hi to Yen.
Hi, Mei. Good to see you here.
Yeah, good to see you too. Yeah.
Yeah, look forward to your talk.
Okay, so now we are moving to the second presenter. Allow me to introduce Professor Kwan Mei-Po by reading her exceptional curriculum vitae. Professor Kwan Mei-Po is director of the Institute of Space and Earth Information Science and Chong Ming Lee Professor of Geography and Resource Management of the China's University of Hong Kong. Prof. Kwan is also a fellow of UK Academy of Social Science, the American Association of the Advance of Science, the Royal Geographical Society, and the American Association of Geographers. She was awarded many outstanding academic achievement awards by the American Association of Geographers, including the Distinguished Scholarship Honor, the Wilbanks Prize for Transformational Research in Geography, and so on. And Prof. Kwan has also received over 57 million US dollars funding support as a principal investigator and co-PI, co-principal investigation, and then she has delivered over 200 keynote addresses, and then invited lectures in more than 20 countries. Today, Prof. Kwan Mei-Po will deliver a presentation entitled Integrating Geospatial Technologies, Environmental Science, and Health Research. Please welcome Prof. Kwan Mei-Po, and you have 45 minutes of a presentation and followed by 15 minutes of a question and answer. Thank you.
Okay, thank you for the kind introduction. Can everybody hear me? Can you hear me okay?
Yeah, I can hear
Good.
you.
So
And
my
then
sound is okay. Yeah, so
yeah.
just want to make sure because you don't know about this Zoom thing. So thank you very much for inviting me. It's a pleasure to see, many different faces in Zoom. So the title of today is that I'm talking about geospatial technologies and environmental science and health research. And then, basically what we do is that we combine remote sensing images and unmanned, UAV, and then of course the GPS, like also positioning system. But so our institute, is situated in this, like also have a satellite receiving station, and we have AI data, big data, processing, and mainly the application is for smart city and healthy cities. So, however, in all of this, like it's important also to have the human behavior and human factors, because eventually I think, what is important is not so much just the environment, but also how the people, interacting with the environment is also very important. So a little background is that, the Institute of Space and Earth Information Science, which is, the ball behind me, and it's a satellite station initiated by the Ministry of Science and Technology of China and the Hong Kong Innovation and Technology Bureau. So basically, however, like we can deal with a lot of geospatial technology, but one is that it's also the human behavior. For example, in this figures, people are moving along, like in space and time every 10 seconds. And then, of course, the third dimension is the time. So you can only move up 10 seconds, data point, because our geospatial technology is at a very fine scale of tracking people. So nowadays, it's very important that we can integrate this positioning in space and time, but also, the different environment, like what is the air pollution, what is the noise pollution, the environmental, information, and also the person's biomarker. For example, like whether the blood pressure is high, the cardiovascular, and all this, information. And this is important because the integration of it, is real time, is very new, and it's also, we call this spatial turn in health research. The fact that we can, like track all this and then integrate them in real time, not, like just overlay with other layers, but basically integrated with the person's real, like real time, biomarkers, and also the behavior we can extract, for example, behavior. So, well, we have done quite a lot of research in the Greater Bay Area, and what is the environment that we are looking into, that we are using geospatial technology to measure. One is that, like for example, the behavior, like eating behavior, cycling, smoking behavior. So it's a really exposure and it's directly affected to health. And then we are talking about physical, like the natural, like green space, like Yan was talking about, like a lot of the policy now are looking into, well, build more green space, and then that leads to, obviously unintended consequences, the built environments and the social environment. Who are you with, right? I mean, so whether this is a high income neighborhood, a low income neighborhood. So we have a lot of exposures, talking about air, noise, heat, radio frequency, electromagnetic field, fast food restaurants is not supposed to be good for you, and then crime. What is good is the green space, blue space, bike path and parks, biking is supposed to be good for you, and also socio-economic advantages. So how do we handle this in our project? So, well, we have built, like multi-source geospatial big database in Hong Kong, and we are extending it also to Guangzhou and the Greater Bay Area. And what it is that we combining, satellite images, the geo-tagged photos, the land use, and also, blue space, vegetation. And then we are using, the street view also, not just from the sky satellite images, but the human-centric remote sensing technology technology, the night at night, and then monitoring station. And then we have similarly, like the noise, across the city in a very fine scale. And we have in Hong Kong all the 3D buildings to, every single buildings. We have it in digital, in GIS, and we have raw network. And then also we have the point of interest, the human behavior, right? So this is a lot of information that we are building up the big database, for Hong Kong and also for Guangzhou. However, just the environment doesn't dictate everything. We can be exposed to the environment. We can even travel to it. However, it doesn't explain a lot of the health information. So this is what I call, the uncertain geographic context problem. It is actually affected, if we only look at the home location, then it might be missing something. The mobility, is important. So the spatial temporal uncertainty is important. And then the agrammatic geographies, is talking about, like in the era of big data, what you use for processing, the big data is also important. And then the nimbus of the neighborhood effect is talking about when we are thinking about GIS, we say, oh, let's do a buffer around the home. And that is the neighborhood effect. That is what the contextual, what is influencing the human behavior and eventually the outcome. But a lot of the time, there are at least two things that I propose is that the idiosyncratic nature of the neighborhood effect. These are all citations. If you want to look at more details, then you can go to take a look. And then you can see that it's a selective mobility, human behavior, right? Then it's very individualistic. And also there's a neighborhood effect averaging problem. And what is it talking about is actually when people traveling around mobility, exposing to pollutions, air pollutions, etc., then that is an averaging result. And that actually would mean that, the neighborhood divided by as buffer around the home may not be so, important. Yeah. So, and then I'm going to use all this methodological concept, to look into a whole bunch of research. First of all, is that we are looking into trajectory data and then looking into how that affect, for example, health outcome like physical activities and others and mental health. And then also I would like to look into the recent research that our group has done on COVID-19. So this is again, what we have seen is that, for every second, we can, intersect with the environment. Mobile sensing is something that I was talking, I was talking about remote sensing, right? Multi-source, using different database. However, the mobile sensing technology using different sensors like the portable sensor is personal monitoring. We can trace the person while they're mobile. Remember the uncertain geographic context problem is talking about, we cannot just look at where your home is, where you stay at home, because most of the time you're probably at work or outside doing something. So we are tracking people along the way in a trajectory with the mobile sensors, different kind of real-time assessment. And also we're pumping them, called EMA, ecological momentary assessment. We're pumping them how they feel, because how they feel is also affecting the behavior. So, and in what follows, I'm going to give you a lot of examples, and then you can look into the citation for more details. And those are, those examples are talking about when we're dealing with geospatial technology in a fine scale, high resolution, then why are we, how do we elicit behavior? And eventually, how does the behavior related to outcome? And then I would like to propose geospatial big data. It's not so much because it's something that we play with, but then explain and predict behavior in a complex way, not just in a simple way. So I'm going to give you some example. The first example, I'm just pointing, of course, there's a lot into the paper, but what I'm talking about is that when we are tracking people, mobile sensing, the real-time air pollution and the space-time behavior, space-time location and time, then we can actually uncover their behavior and their exposure to air pollution in a very complex way. So how do we do that? This is a lot of words, and of course, this is a paper that you can read, but basically we are comparing 3 types of individual level exposure. For example, we put air pollution stationary sense, like stationary monitoring station. And then we are looking into what is around the home, about this person. And then this is individual, but this is static, like residential-based assessment. We can also looking into when people are traveling, the trajectory, overlaying with the monitoring station assessment. And we are also looking into the mobile sensor, tracking them and the air pollution at the same time. I'm just going to show you the result. I mean, of course, people moving the air pollution in every 1 second that we are monitoring them. And then with all the static, station, either mobility-based or residence-based around their home or tracing them. But if you use the stationary, like this putting in sensors of air pollution in a station and in Topole, then it's very different than the second by second, personal monitoring of the air pollution. So this is every second there's a data point, right? And then especially, for example, when at home cooking, and it's highly related to the kind of activities the individual is doing. So human behavior, also affect how they're exposed to indoor, outdoor. So this is why we're tracking people in a very refined way. This is every 3 hours, but we're also having it every 1 second. So this is, again, there's a lot of result. You can go and read the paper, but basically what this is my point. And then also a second point is that this is Baltimore data that we are tracking people again, second by seconds, and about not just where they are, but also their feelings about craving for drugs. And when we do that, we have a lot of, like different, about stress, how they're stressed in different locations. And we have a very counterintuitive finding is that people, when we say that this is a very not good, negative, like high crime area, actually people feel less stressful and a bit more positive mood, and less craving for the drugs. So this is again, an illicit, very complex behavior. So I have a lot of material, so I'm going to go a little bit quicker. So what else can we do with spatial big data and geospatial data analytics? So we can, for example, look into emissions. We can estimate, energy consumption. We can do, individuals' daily travel. We can look into this CO2 emissions pattern, and we can also, look into pathfinding. So again, just very quickly, all this published the paper if you're interested. So basically, when we're looking into the estimation of emissions and fuel consumption, we build a multi-dimensional space-time path. And then we have a speed, CO, hot, cold, emissions, and engine off, and engine off. And then we can use this very refined, again, second by second, taxi trajectory data. We estimate fuel consumption and emissions of the mobile activities. And we find out that basically there's equations and then a result. But what I want to talk about is that also when the engine is idling, stop, then has a very notable impact on the fuel consumption, and congestion during rush hour lead to particularly severe fuel consumption and emission problems. So the implication is that turn off the engine would be a big help. Another thing is that when we are dealing with big data and uncovering complex human behavior, we also have done spatial flow co-location pattern discovery. So when we have people moving around, so what are, basically a lot of the time people look into co-location in either the origin or the destination, but we're looking into whether the flow from the same origin to the same destination, would there be a co-location, like two people? Would they started from the same origin, like same, district A going to district B, pattern, and how do different social groups experience different spatial co-location in the dynamic context of daily commuting? So so we just look into all all of this, yeah. And then the important is that if we just look into just the residents of the workplace, we cannot uncover commuting, for example, more complex behavior. So for example, we have this framework. Again, it's already published the paper, at least it's online, so you can go to look at the details. So I'm not going to explain, but instead I'm going to talk about the result using Chicago Metropolitan Agency for Planning GPS data, that we are looking into all the complex homework commuting flows of participants. And we find out that with managerial and education, instruction, and library occupations, there are different occupations, right? The co-location index for the home and for the work are high. However, the flow co-location does not exist. So this is the complexity of the co-location, but with business and financial operation and computer and mathematical occupations, and all three are yes. Yeah. So again, so we have to look into different social groups and look into the complexity. Yeah. So another one is that we are also using geospatial. Actually, I'm doing quite well in time, so I don't have to be too nervous, I think. Yeah. So another thing is that when we are looking into, trajectory big data, space-time big data like GPS, and you are using a smartphone, accelerometer to look into physical activity classification. The key point is that, well, I mean, if I only have you only have the phone turn on, does it mean that you can actually know where people are sitting, jogging, running, or you're sitting, but you're sitting in a car, it's still moving? So I think that this is what we use AI and machine learning algorithm, and then, to look to, basically classify, to generate training models and classify the status physical activities, so that you have to tell us, minute by minute, oh, I'm sitting now, I'm jogging, but we will know. Just turn on your phone, then we already know what you do. So this is the predicted class, and our result is all over 98%, 99%. So it's very accurate. And then we also have indoor, outdoor classification, whether inside or outside. And also we have, looking into, in vehicle, or sitting in vehicle or standing in vehicle. And then we are thinking about, then can we use this classification so accurate over 90% most of the time, and actually 98 or 99% most of the time? Then can we use this, GPS trajectory, people moving around, and then also classifying, whether they're running, jogging, they're actively traveling, are they biking? All this, and is it related to the environmental context? So then my former PhD students, for example, came to see me and say, I want to buffer every single GPS point in the data set, and then it's a big data analytical, and then I need a supercomputer. So then I asked him that, why do you need a supercomputer while you're buffering every single GPS point? And then when you buffer different size, there may be uncertainty in it. So I say, okay, then we will do it. And then so we decide to be 5-second in interval. And then we are looking into, machine learning and algorithms, looking into different kind of sizes of the buffer. And then we run multinomial logistic regression, examining the association between active travel mode and environmental context. Active travel mode would be whether you're walking, you're biking, you're in vehicle, but you're sitting, and in relation to the trees, parks, open space, transit, accessibility, crime, and travel and traffic collision. And does it related to when you see open space? And this is the supercomputer that we use. And then we find, just very summary, the result is that, well, we find that, particular, walking is associated with high tree density, high transit availability, battery incidences, and more traffic collision. And then on the other hand, buffer areas of the GPS one associated with biking had an average more parks and open spaces and higher neighborhood medium household income. And so this is some of the result. And also a very important finding is that the buffer size, whether you're buffering big or small, then you have some uncertainty. The association change the effect of buffer size are significant, different. And then this is what I call the uncertain geographic context problem. Depending on the size of the buffer, or identify, mobility versus residential, you got a different association between the environment and, the health outcome, and then so-called the active travel mode in this particular case. And then we also have done the behavior, like using trajectory data, that people have different kind of travel patterns, and we do contact-based, activity-based, and we have using different way. And this is the one that we developed, context-based, crystal growth, activity-based behavior. Basically, we also use a big data, 6 million cells just in one county, the Cook County, where Chicago is located in the United States. And then we are doing 100 by 100 meters, and we are doing hexagons, like weighted plane of Chicago. And then we grow, crystally, the activity space of the individual. And we found that this is actually much fitter to the physical activities associated better than the other kind of activity space, approximation. So this is all that, we are elicit, complex human behavior using, geospatial technology and geospatial data and the theory about uncertain geographic context problem. Then how about COVID? We actually have done a lot of COVID research, in the past, 1 or 2 years. And then we found that it's very interesting that to use geospatial technology to actually to look into the reduction of social inequality of COVID risk through contextual analysis and geospatial big data analytics. So the first one is that, we use big data environment. Remember that we have spent a lot of time using different kind of remote sensing, 3D, and also, to look into, all this, and this flipping by itself. So I'm trying to control it a little bit. So, and then we also create this big data set, social context, and we are looking into space-time patterns of high-risk area of COVID, and to support policy making for effective and targeted mitigation measures. And we are also having vulnerable population facing high risk of COVID-19, provide useful insight for reducing social inequality. And and then the big question is that why are we still in trouble? Why are we still locked down? Why can't I just travel to see Yan without any quarantine? And why are we still dealing with COVID after almost 2 years? And I think that one of the major reasons is also people's perception and privacy concern of COVID-19 mitigation measures. So maybe there's a restriction, but people may not observe it in every country, and not everyone is observing it. So, and by looking into, we also have done study on people's perception and privacy concern. We are hoping to help the government implement more acceptable COVID-19 mitigation measure. So this is our website. We have 4 areas of research. We are also looking, by the way, the uncertainty in the assessment of COVID-19 risks in addition. And then we have quite a lot of publications already. And then if you're interested, then you can go to the website and then look into these papers and in more details, because what I can cover is just highlight of some points. So basically, actually, there's quite a lot of invitation all around the world, including Australia, actually, the Netherlands, UK, US, because, the COVID-19 research, I think that we have some pretty good findings in it. So the first one is that I want to talk about is that how does COVID-19 affect mobility? Well, there's always a restrictive, restriction that people should be social distancing, people should not move around, lockdown, and all this policy. And then so the purpose is that we are going to look into how COVID-19 policy is impacting on people's mobility. The first studies that we're doing is in the US county level daily mobility. And then we are using big data like mobile phone data, and then of people in the county. And how we do is that we are defining something called, individuals maximum distance from home. And then we have everybody, because it's mobile phone data, right? So it's mapped to the cellular tower. And then we are defining what is, the daily mobility level, the medium selected, and then and then, of course, we run many models, and this is a longitudinal model. So we're actually looking into period when COVID first starts the travel. And then I think that maybe, it's difficult to just talk about all the models and, oh, my internet is unstable. Can you still hear me? Yeah, if you cannot, please let me know.
No problem. Go ahead.
No problem. Okay, okay.
Yeah.
So I think that, I just summarized the result because the models are very complex and difficult. I mean, there's quite a lot of details. But what I'm trying to say is that there's a consistently V-shape that we observe. V-shape is in the beginning of COVID, mobility dropped, but very quickly pick up, to the normal level and maybe even higher. So despite of the strictness of this, statewide policy. So basically all these are modeling result, right? But so what we're talking about, a large decrease in the mobility level during the P0. However, after the post-0 is quickly move up and consistently fall. We have done many variables, but I'm only picking, the strictness of the state policy is still a V-shape. And then the poverty level is V-shaped, but in a very different way. So people, in low-income counties go down, but not very much. But and then pick up, and so they are not affected by those policies because they're essential workers and they have to work. So this is a social justice dimension here. So people are more likely to travel as usual, even at the earliest stage of the COVID-19 pandemic, because of largely essential workers like supermarket, workers and etc. So this result interesting concept. So of course there's other variable like partition, whether they're Democrat or Republicans, but I'm not going to go into all this model detail. But this V-shape is very consistent and it's very interesting because especially the wave 2, after the knot, actually COVID is even higher. Then you would expect that when COVID is higher, the restriction is tighter, and then the mobility will be lower, but actually it's not. So that means that there's a quarantine fatigue, there's a behavior, and then also decreasing perceived risk among the population, and then this V-shape is consistent, not just in the US, but we have done studies also in Hong Kong and then also in New Zealand and UK. I think we found, persistently this, impact on the mobility. And then another risk area of COVID. And then in Hong Kong, we have done space-time, spatial temporal scan statistics, and we find out that, as time goes, first is imported cases, and then it go to local, and it's adversely impacted on the low-income people. And then, and it's very highly related to the policy, and also overseas situation, and then the social distancing rule. Again, all these papers are published, so I let you to look into it. So what is interesting is also we in Hong Kong, I think we have collected a set of data, or we construct, to be more precise, a set of data that is individual. So we constructed the space-time path of the infected person, and how their movement and their work home location, we actually have it to the building level, where they live, in a building level, and then we're constructing the path and the space-time trajectory of individual expected to different high-risk environment. Actually, this paper is already online. Journals of the AAG, the flagship journal of the AAG. So what we did is that actually we did quite a lot, but to highlight what we used, this individual level data, we pretty much construct, the infected persons, like space-time path, and then we construct the 6 different activity spaces of them using 6 different methods used in the study, and we are, contextual analysis to look into the COVID-19 risk by individual mobility. And then, so remember that I talk about the uncertain geographic context problem, the uncertainty in the assessment of COVID-19 risk. So we are looking into 2 types of, locations. One is case-based, the building where the person pretty much, we know the gender and we know the age. Yeah, actually we know quite a lot, and those are published, like this, and we construct by using multi-source information. So the location with the person later confirmed to be infected, and also we look at where they visit, the venue. like where they flew in the last 14 days, all the venue that they have been, the bars and restaurant. And then we put it into, like space-time cube, like space-time, and the third dimension is time. And then this is the trajectory part of this infected cases, travel through, and then we buffer them. And then we build so-called the venue-based, and then also, and also case-based, like high-risk areas. And then what we do is that, again, it's the same paper that we look into mobility-based approach, the residence-based approach, and also we build 6 activities-based approach. And then we put it into regression models. And the result is that the mobility-based approach obtains most reliable result when compared to other methods when assessing people's COVID-19, risk. And then, as you can tell, if you're only looking into the static, like home-based, risk, and that is missing quite a lot, of how COVID-19 would be risky to people. So we have also conducted more diverse activities in their daily lives tend to have a higher COVID-19 risk. So the conclusion is that ignoring people's daily mobility and its interaction with the complex dynamic COVID-19 risk environment can underestimate COVID-19 risk, which may lead to ineffective, control measurement. And then we also look into, remember I talked about a neighborhood effect averaging problem, right? Supposedly, if you're moving around from high to low, and then eventually it would be, kind of average the result of your COVID-19 risk. However, not every population would be able to move around equally. And so specific social groups would have do not have an option to decide which trips to make or to forego, because this is talk about constraint, maybe disadvantages in NEP. So we are trying, first of all, we want to find out, is that a NEP effect, neighborhood effect averaging problem? The answer is yes. And then which social group is actually more constrained to not to be average, like their risk due to, like by moving around, because they cannot move around. For example, we've identified 2 groups in our data. One is low income, live in a low risk neighborhood and have to work in location with a high density of high risk venue. And the other group is also low income, but live in high risk neighborhood. Supposedly they're moving around to a low income, not low income, but move around to a low risk neighborhood, but cannot due to their, like for example, occupations and their disadvantaged status. So individuals who have the option of deciding which trip to make can limit their exposure to high risk area. For example, they can, like in the COVID time, they can work from home or etc. Conducting daily activities in a low risk neighborhood in a more open and high class expensive neighborhood. So we have constructed, again, so this, so then we basically find out, NEP, is an important, issue to look into, because NEP exists, however, not applying to every single special social group. And environmental justice and also in COVID-19 also exists in a big way. And then we elicit all the very detail, exactly which social group and why they cannot, overcome the disadvantage of exposure to COVID-19 risk because, of their daily, their constraint, like low income, they don't have a choice, and etc. So, and then we are also thinking that, people interact, right? They're not just, like having exposure, but people have the social connection, contextual analysis, and we are also combining the mobility sensing with the contextual analysis and the epidemiology modeling, provide useful insight for reducing social inequality. So this is, a free cases, they are friends and they met in the bar and then they got infected, like COVID-19. Case 1 and case 2 actually are colleagues, but they did not get infected in work. And then they're moving around, in time. Case 3 actually stay home quite with observing social distancing restriction. They're not going out, but except going to the bar and got infected and went to the hospital together with the same day as case 1. So all this social interaction by reconstructing the contact place, then we are looking into, how they spread by the building level. By the way, we have the data of the individual or by the building level with time. So we are able to look into the super spreading places. Sorry, it's moving by itself. So we are with epidemiology modeling, then we are doing super spreading places modeling on the high risk super spreading places in Hong Kong. This is to the building level, and also to a block group in Lan Kwai Fong, the bar areas. And then and this is already appeared and published in Health and Place. Yeah. The last paper that I want to talk about is that I'm doing actually quite good in time. So I'm going to take a little bit time of talking about how important, this research is a lot of the time, all this mitigation measure may be in effect, but not everybody observing it. And that's why we are still having quite a, there's a vaccine, but not everybody, taking it. So people's perception and the perceived social benefit and acceptance of the mitigation measure is a very important. And the project investigate people's acceptance and perception of different COVID-19 mitigation methods and propose geoprivacy protection measures to address people's privacy concern. For example, what are the mitigation measures that using locational information is very sensitive, because if people are tracking you, when traveling, remember this is like you have to do a barcode and scan QR code when you go into a bar or restaurant. And then potentially, this is mostly done by Bluetooth, but it can also be GPS. So we are studying 10 different mitigation measures about location, using location information. In the first group, M1 to M4 is GPS location for mobile phone, for example, credit card history, and then also, using GPS tracking. And then later on, then we are using, for example, during quarantine, what do people use? Like e-wristband, following them when they're quarantined, and also the travel certificate. And the last two is that you are basically, telling people, that, what is your location is. And so we find out that, we compare 3 different countries, Hong Kong, South Korea, and the United States. And then, the purple is Hong Kong. So we find out that the privacy concern, people are very concerned about travel certificate. They don't want to expose, let people know that, like where they have been, whether they got the vaccine, and then using those going to, and of course that maybe why we're still locked down in this part of the country, even though we basically have many days 0 cases. But because we don't really have a good travel certificate agreed by other countries. And another one is that East wristband, actually they're willing to wear this, like less privacy concern. And then of course their counterpart is that, they're less accepted, travel certificate, and more acceptance for the, East wristband. I think in all countries, the GPS location tracking are not very concerned and not very accepted, the acceptance rate is very low. However, the acceptance of all method tends to be the highest in South Korea. And then we said that culture shape how, perceived risk is. And then the acceptance of contact tracing method using digital contact tracing. I'm not talking about just asking people. I'm talking about GPS tracking, digital contact tracing, and self-quarantine monitoring of travel certificate tend to be accepted very low to US and Hong Kong. And Hong Kong people have very low acceptance of tracking technology. It's like using GPS locations and travel certificate, but it's more acceptable to use the bracelet to monitor people in quarantine at home. So this is, result is important for forming the government's policy. And we just got funding to extend this study to 3 more countries, which are the UK, New Zealand, and also Japan, because they represent different collectivity, orientation, different culture, and different mitigation measures. So, okay, so I think that I can, conclude comfortably using my time, and then open for questions. The first one, the conclusion is that we use smart data technologies. And this is a very state of the art, by the way, personal sensors, GPS tracking, a new method also, you know, like we have actually, in the meantime, we have to develop a lot of new big data analytics and also machine learning and all of the above, you know, like to analyze behavior. However, we are happy that despite of so much work, I think that we actually elicit very complex behavior that eventually affect health outcomes, you know, like, for example, COVID-19 risk or physical activity where the people are moving around, be more healthy. So the aim is to improve health and well-being of all citizens. Because we're individual based, you know, most of the data, and individual is human, right? I mean, different people. And because it's individual based, we can distinguish male versus female, elderly versus young age, high income versus low income, etc. Understanding, explanation, and prediction of complex human spatial behavior. So when we build a big data analytics like the spatial collocation flow analysis, then we are not just building it because mathematically it sounds elegant, but we actually want to understand what social groups, you know, actually can have a collocation that is different than just looking into home and, you know, like work, etc. And then eventually, a lot of our work, like the mobile sensing, personal sensing, and also the COVID perception. And then we are doing across different countries. And because I do believe that international comparison can be a very, very fruitful direction because it looked into different contexts, right? So when you cross a country or cross a region, then you're looking into different culture, you're talking about a different landscape, different physical, social, or built environment. And I think that those comparisons can shape a lot of lights, you know, into what we can talk about geospatial technology, environmental science, and health research. And with that, then I will conclude my talk. And thank you for listening. I'm done.
Well, thank you. Well, thank you very much for delivering this interesting topic with actually with extensive coverage of data, which is very interesting for us. So we have 15 minutes for question and answer, and then I think we have already one question in the chat box. So this is the first question from Munawar. Thank you for the enlightening presentation, Prof. Mei. I would like to ask some question how to do data mining or to get some kind of geospatial big data to get spatial information of human behavior if we don't have any volunteer to do the experiments. So this is the first question, I guess. And then the second question is, do we mine the data by accessing information from the internet or cellular phone provider or a Google account location history? Thank you. So
oh, it's a very good question. Thank you for the question. I think how to mine the data, basically, you know, like because it's such a big data set, geospatial big data set, and the human behavior, and it's actually needs, you know, like, so there's a, you know, algorithm, you know, like, for example, AI, machine learning, there's some kind of specialized, you know, like data, you know, like methods, and then maybe that needs to be picked up. I don't know whether it's a student who's asking me, then you probably need to take a class or ask, you know, your RA to take a class. And that is, you know, a big data analytics is a new field. So I think that there are classes that to be taken. And so, and also, you know, a lot of the time, you know, like the normal computational power may not be enough, like just machine, the computer. So maybe it needs a supercomputer, like you know, the buffering of every GPS points, you know. So I think that, you know, like that, I think needs to be picked up. And also the technique, and when you operate on a supercomputer, it's not just the normal programming. I think it's a whole different kind of programming. So I think that when I train my student, then they need to go through a series of classes and to do this. So this is one, and depending on your purpose and your operation, I think that maybe there's different, you know, methods to be done. So this is, I hope that answers your first question. The second question is that it's a very good question also. I collect all my most of my data, or I reconstruct them from different things. I just basically, like I have like a team of 30 people going outside to the field and to recruit people to move, carry, those sensors around. So this is a data collection, but some of them you can also use mobile phone, and then you can buy it from the mobile phone, provider, and they're usually quite expensive, and they will also not letting you to have the social demographic because it's confidential, right? So you just cannot, let them know, is a female, age 32, and then who is, moving around this way. Google account location history, I think that you can also get some of those. I think that depending on what you need, then I think that you can pretty much get some of the data by the volunteers also. But if you really want to address your research question, then I would suggest you to collect your own data if it's feasible. Yeah. Okay. So I hope I answered the question. Yeah.
Well, thank you very much for the answer. Is there any other question for Prof. Kwan? Otherwise, I will ask her one question, a simple question. What is the difference between sitting and standing based on the GPS data?
Sitting and what, sorry?
And standing.
And standing.
Yeah.
Oh, okay. Yeah. So, well, basically, it's in the GPS data, it probably show the same location, but we also would carry, like we'll have accelerometer. So standing and sitting would have the movement, a little bit different. I think that's how we train our data set to distinguish the two. Yeah.
Yeah, thank you very much.
So it's not just the GPS data, it's also the accelerometer that they're wearing. Yeah.
Okay, well, thank you very much. Do we still have a question here? Any other question from the participants? No question.
Okay, so I would recommend, if you have time, then to read some of the, publications, and I think that a lot of the details is also be in the papers, and then of course you can always contact me, and then we can have more discussion. Yeah.
Right. Yeah, thank you. Well, thank you very much. I think that is all for this presentation, since we don't have any other question. Thank you very much for this interesting discussion. From this presentation, we know that advanced geospatial and mobile technology can provide new insight, I think, on the relationship between human health and people daily mobility. Thank you very much, Prof. Kwan, for addressing this interesting topic. So this is the end of this plenary session. Thank you very much for all speakers and all participants. The next session, let me check. The next session will be the invited speech by Dr. Agustan in room 2 and GIS workshop in room 3. So thanks again, and then I do hope that all of you can enjoy this conference. So thank you very much.
Yeah, thank you for inviting me. Yeah, bye-bye.
Bye. Thank you very much. Bye.